Welcome to True Projects. In this video, we are going to explain about our project titled Emotion Detection Using Machine Learning. Emotions are fundamental to human communication and understanding, and this project aimed to leverage of deep learning to analyze and comprehend the emotional content and textual data. By employing the LSTM, a specialized type of recurrent neural network, we seek to capture intricate sequential pattern and the contextual dependencies within the text, enabling the more accurate emotion prediction. Through the extensive training on the diverse data set containing off-label emotion expression, our goal is to develop a sophisticated emotion detection system. This system potential applications are vast, ranging from enhancing the virtual assistant emotional responsiveness to revolutionizing the sentiment analysis and the social media and the customer feedback analysis. The objective of this project is to create an advanced emotion detection system using LSTM network. By leveraging the power of deep learning and recurrent neural network, our aim is to develop a model capable of accurately identifying and classifying the emotions within the textual data. We will curate and pre-process a diverse data set with the labeled emotional expression to train the LSTM network effectively. The project seeks to achieve higher accuracy and the emotion prediction, especially in capturing the contextual dependencies and the sequential patterns that are present in the text. Through the rigorous experimentation and the optimization, we aim to create a robust emotion detection system with the broad applications, including the sentiment analysis and the social media, personalized user experience and the virtual assistants, and improving emotional understanding in the human-computer interactions. Ultimately, our goal is to contribute to advancement of emotion detection technology and its integration into various real-world domains. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, we import the necessary Python libraries required for our emotion detection project. Commonly used libraries include Pandas for data handling, Matplotlib or C1 for the data visualization, sklearn for machine learning, and the TensorFlow for building the LSTM model. And the second one is importing the dataset. The emotion detection process necessitates a labeled dataset containing of textual data and the corresponding emotion labels. This dataset will be used to train and evaluate the LSTM model. The dataset is loaded into the environment for the further processing. And the third one is data visualization. Data visualization is crucial to gain the insight into the dataset distribution and the characteristic. We create the various plots and the charts to visualize the distribution of the emotions, checking for the class imbalance and explore the textual data length and the patterns too. Visualization aids in making the informed decision during the data pre-processing and the model building. And the fourth step is data cleaning. It involves handling the missing value, removing the duplicate records, and addressing any noisy or irrelevant data. Textual data is pre-processed by converting all the text to lowercase, the characters and the punctuations, and applying the tokenization to split the sentence into the individual words. Data cleaning ensures the dataset is in the suitable format for training the LSTM model. And the next step is splitting into the training and the texting. To build and evaluate the LSTM model effectively, the dataset is split into the two subsets, the training set and the testing set. The training set is used to train the LSTM model on the labeled sample, while the testing set remains unseen during the training and is utilized to assess the model generalization and the performance. And the next step is building the model. Long short-term memory networks are specialized type of recurrent neural network designed for handling the sequential data such as test, time series data, Unlike the traditional RNN, LSTM network have a unique memory cell that can retain the information for the longer period, allowing them to capture the long-range dependency and learn intricate sequential patterns effectively. In the context of emotion detection, the LSTM model is constructed with several layers, including the input layer to receive the textual data, LSTM layers with an appropriate number of units to process the sequence, and the output layer with the nodes representing the number of emotion classes to be predicted. During the training, the LSTM model learns to adaptively weight the importance of different words or steps, recognizing which word contribute to more determining the underlying emotion. And the next step is training the model. During this phase, the LSTM model is trained using the pre-processed training dataset. The model learns to associate the word sequence with the corresponding emotion label, optimizing its parameter through backpropagation and the gradient descent. The training process continues for the several epochs until the model achieves the satisfactory level of accuracy. And the next one is user gives the input. To enable the user interaction, we use a user-friendly interface such as the web application of Flask, where users can input the textual data for the emotion detection. The input test is collected from the user and passed to the next step. And the next step is the given input is pre-processed for prediction. The user input is pre-processed in the same manner as of the training data. This involves converting the test to lowercase, removing the special characters and punctuations, and tokenizing the test into individual words. And the next step is trained model is used for the prediction. The pre-processed user input is passed to the trained LSTM model for the emotion prediction. The LSTM model processes the input sequence, capturing the underlying sequential pattern and the context, and produces a probability distribution over the possible emotion classes. And the next one is final outcome is displayed. The emotion prediction from the given user input is displayed through the interface. The final outcome includes the predicted emotion label, the associated confidence, even a visualization of the emotional intensity across the different classes. The user gains the valuable insight into detecting the emotion, enhancing their understanding and engagement with the model. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the dataset folder containing of the dataset that we used in this project, and the model folder containing of the H5 file, which likely contain the information related to the algorithm and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operations. And the static folder containing of related to the CSS, JavaScript, Bootstrap, fonts, images, assets within it. And the template folder containing of the HTML documents it likely include home, index, notebook, results, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. And the model and the notebook is an IPYNB file which contains a combination of code. The user to write and execute the code in the individual cell, making it a popular choice for the data science. And the sign-up will be the database file user to store the user information. And for the execution, we build a Flask framework as of runtime. And for the total code is present in the notebook IPYNB file as a combination of code, graph and output all in one place. And for the execution, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command cd space and paste this code folder path. By using this, it will change the current directory to the code folder path, and then write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on the enter button By this, the app.py file will run on the Flask framework. It will produce an default address like this. We need to copy this default link and paste it on any of the web browser of our choice. And I prefer use of Google Chrome. I'm pasting this and then opening this link. Here we can see that the title of the project and the sign in and sign up buttons. Then click on the sign up button. Here it will redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page. It will redirect to the sign-in page containing of some details that need to be filled of username and password as of admin. I am clicking on this login button. Here it will redirect it to this login page containing of one text box. Here we need to give the review. Based on that review, it will predict the message. And here I am writing the review as I bought this tablet for my 4-year-old daughter. Too many advertisements. I would rather pay more and not having a single ad. And then click on the predict button. Here the predicted result as of neutral. By using the try again button, we are redirected to this index page and we can enter the review and this. And here I'm entering that review as I'm happy by using this mobile because its display is simply amazing. And then click on the predict button. Here the emotion is predicted as of very positive. And by using the try again button, here we can redirect and re-enter the another message as of bought a Bluetooth headset and the noise cancellation is not available, but in the detail section they show me it's available. I am not happy for the product. And then click on the predict button. Here it reviewed as positive. And this way we can detect the emotion using machine learning. And in conclusion, the project has successfully demonstrated the effectiveness of using LSTM network for the emotion detection. The LSTM model trained on the diverse data set exhibited the commendable accuracy in predicting the emotional content from the textual data. By leveraging the power of deep learning and the recurrent neural network, we have achieved a robust and efficient emotion detection. Thus, the result opens up the exciting possibility for the real-world application, including the sentiment analysis and the social media, personalized user experience, and the virtual assistants and the customer feedback processing for the business. This project marks a significant step in the advancing the understanding of human emotions through the machine learning and its potential impact on the various industries.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.